A problem to prove. Two angles are in different planes, but each side of one is parallel to the corresponding side of the other and has also the same direction. Proves that such angles are equal. What we have to prove is a fundamental theorem of the solid geometry. The problem may be proposed to the student who are familiar with plane geometry and are acquainted with those few facts of the solid geometry which prepare the present theorem in Euclid elements. The theorem that we have started and are going to prove is the proportion to 10 of the book 11th of the Euclid. Not only questions and suggestions quoted from our list are printed in italics, but also other which corresponding to them as problem to prove correspond to the problem to find. These correspondences are worked out systematically in the problem to find, problems to prove 5-6. What is the hypothesis? Two angles are in different plane. Each side of the one is parallel to the corresponding side of the other and has also the same direction. What is the conclusion? The angles are equal. Draw a figure, introduce a suitable notation. The student draws the list of the figure 4. Yes. And chooses helped more or less by the teacher, the letter as in figure 4. What is the hypothesis? Say it, please, using your notation. A, B, C are not in the same plane as A dash, B dash, C dash, under AB parallel A dash, B dash, AC parallel A dash, C dash. Also, AB has the same direction as A dash, B dash, and AC the same as A dash, C dash. What is the conclusion? Angle BAZ equal angle B dash, A dash, C dash. Look at the conclusion and try to think of the familiar theorem having the same or similar conclusion. If two triangles are congruent, the corresponding angles are equal. Very good. Now, here is a theorem related to your and proved before. Could you use it? I think so, but I do not see yet quite how. I think so, but I do not see yet quite how. Should you introduce some auxiliary element in order to make its use possible? Well, the theorem which you quoted so well is about triangles, about a pair of congruent triangles. Have you any triangle in your figure? No, but I could introduce some. Let me join B to C and B dash to C dash. Right. Then there are two triangles. Triangles ABC, triangle A dash, B dash, C dash. Well done. But what are these triangles good for? To prove the conclusion. Angle BAC equal angle B dash, A dash, C dash. Good. If you wish to prove this, what kind of triangle do you need? Congruent triangles. Yes, of course, I may choose B, C, B dash, C dash, so that AB equal A dash, B dash, AC equal A dash, C dash. Very good. Now, what do you wish to prove? I wish to prove that the triangles are congruent. Triangle ABC equal triangle A dash, B dash, C dash. If I could prove this, the conclusion angle BAC equal angle B dash, A dash, C dash would follow immediately. Fine, you have a new aim. You aim at a new conclusion. Look at the conclusions and try to think of a familiar theorem having the same or similar conclusion. Two triangles are congruent if the three sides of the one are equal respectively to the d side of the other. Well done. You could have chosen the worst one, and now here is a theorem related to yours and proved before. Could you use it? I could use it if I knew that BC equal B dash C dash. That's right, thus what is your aim? To prove that BC equal B dash C dash. Try to think of the familiar theorem having the same or a similar conclusion. Yes, I know a theorem finishing. Then the two lines are equal, but it does not fit in. Should you introduce some auxiliary element in order to make its use possible? Make its use possible? ... You see, how could you prove BC equal B dash C dash? When there is no connection in a figure between BC and B dash C dash? ... Did you use a hypothesis? What is a hypothesis? We suppose that AB parallel A dash B dash AC parallel to the A dash C dash. Yes, of course, I must use that. Did you use the whole hypothesis? You say that AB parallel to A dash B dash. Is that all that you know about these lines? No. AB is also equal to A dash B dash by conclusion. By construction. They are parallel and equal to each other, and so are AC and A dash C dash. Two parallel lines of equal length. It is an interesting configuration. Have you seen it before? Of course, yes. Parallelogram. Let me join A to A dash, B to B dash, and C to C dash. The idea is not so bad. How many parallelograms have you now in your figure? 2. No, 3. No, 2. I mean, there are 2 of them which you can prove immediately that they are parallelograms. There is a third which seems to be parallelogram. I hope I can prove that it is one, and then the proof will finished. We could have gathered from his foregoing answers that the student is intelligent, but after this last remark of his, there is no doubt. This student is able to guess a mathematical result and to distinguish clearly between proof and guess. He knows also the guesses can be more or less plausible. Really, he did profit something from his mathematics classes. He has some real experience in solving problems. He can convince and exploit a good idea. Right.